Hi children, this is SS, your physical science facilitator from Commando Group of Schools. Welcome to the online classes. Children, in the last class we learned a graphical representation of x-axis, y-axis, maybe displacement, distance and etc. And average speed, average velocity, those things. Now let us see what is the instantaneous speed. Instantaneous speed. Okay. Instant. You know the meaning of instant? Immediately. So, especially in the intermediate, the children who left over or who failed, immediately they wrote exams, instant exams. So, without wasting of the academic year, immediately they are going to conduct instant exams. Instant means immediately. So, instantaneous speed means the speed of the vehicle or the speed of the object at the particular time. At the particular time. Okay, so instantaneous speed means the speed at the point of time. The speed of the object at the point of time. Speed of the object at the point of time. If you want to identify this instantaneous speed, you know, speedometers are there on the vehicles. Speedometers. The speedometers will give instantaneous speed of the particular vehicle or object. That's about the thing. Now, we will go for another concept, another important concept called acceleration. Acceleration. To understand this concept of acceleration, okay, children, don't neglect that you are not having a board exam, that 9th class, like that, because these concepts are very crucial where your life is going to decide. In the competitive examination, maybe IIT, mains or maybe NEET, like that. Life is going to be decided there, no? So there, most probably the concepts will come from these topics. You may observe the previous question papers also, you can easily analyze. Based on the concept, the questions are coming. So don't neglect the concepts which are present in the 8th and maybe the 9th and 10th. Okay, don't think like that we are not having the board exam, so no need to study, like that. So each and every class and each and every concept is very important to give you a fruitful life and the content. Right, now we will see some activities to understand this acceleration. When the body is said to be accelerated, for that purpose we are going to do some activities. Okay, let us see about that. Okay children, let us see this activity. Now, I want to send this ball towards up. So, I am specifying the direction also. So, towards up. In this direction, I want to send this ball. So, I am going to apply some force. So, see this? So, it's moving like this. Up. It's moving up. Means, here you have to realize one thing. The direction is not changing. When I am going to apply some force, gradually its velocity is decreasing. When the object is moving up, its direction remains constant, but velocity is decreasing. So here what is constant? Direction. What is going to be the variable? Velocity is changing. Now I am going to release this ball from the top. So gradually its velocity is increasing. And it's moving in the same direction. So during this, when the ball is moving up, or when the ball is coming down, which is going to be the constant, direction remains constant. And what about this? Velocity is changing. When the ball is coming down, velocity is gradually increasing. When the ball is moving up, velocity is gradually decreasing. So children, you understood one thing here. One is constant, one is varying. What is the variable here? Velocity is changing. And direction remains constant. Understand this concept? We will apply the content. Okay, children? Already you saw what is happening when the ball is rotating like this. One plan. And this one plan. So, on the surface of this plan, one ball is rotating. It's moving down in this direction, and also like this plant. We send the ball up. We send the ball up like this. In this case, what you observe? The direction is same. The direction is same. Upward. Here, downward. So the direction is downward, continuously downwards, continuously upwards. But what is changing? The velocity is changing. In case 1, velocity is changing, direction remains constant. Right? Let us go for the second concept. In this second concept, you may see what the body is doing. It's rotating. When I am going to release the force at any one point, I am going to release the force. Then what happens is, you may see, from where I release the force, from there, it's moving in tangential direction. From that point, it moves in tangential direction. That's about the case 2. In case 2, the body is doing uniform circular motion. Uniform circular motion. Uniform circular motion means its velocity, okay, angular velocity, means the magnitude of velocity remains constant. For example, here its velocity is 10 meters per second, but in this direction, okay, from this point A. Now the object reaches point B. Here what is the direction? Tangential direction. So here it may be towards north, here it may be towards west. Now children, now tell me the velocity of the object at B towards north. I understand the point. Carefully observe the concept here. The object is doing uniform circular motion. The object is doing uniform circular motion means the magnitude of linear velocity remains constant. Magnitude means only the quantity. 10 meters per second. Here also 10 meters per second. 10 meters per second. But what is the direction? Towards west. Here at point A, velocity is 10 meters per second. At point B, 10 meters per second. But at point A, what is the direction of velocity? Towards north. What is the velocity of the particular object at point B? 10 meters per second. But towards west. Now, at this point, I want the particular object velocity towards north. Is there any velocity towards north? No. So, 0. 0 meter per second towards north. Remember this concept also, case 2. What is constant in case 2? Velocity remains constant. The magnitude of velocity remains constant, but continuously the direction is changing. It is contradiction to the case 1. What is happening in the case 1? In case 1, the velocity is changing, but direction remains constant. Towards down. We confine the direction. Downwards. Direction is there. Velocity gradually increases. Change in velocity. If you see this one, upward direction. So direction is given upward, but when it is going towards up, gradually velocity is decreasing. So velocity is changes. Clear? But in the case of here, uniform circular motion, the magnitude of linear velocity remains constant, whereas the direction is changing. If I want to identify at the point C, what is velocity at the point C? Yes, very good, 10 meters per second only, but towards east. So direction has changed. Clear? It's about case 2. Let us see case 3. In case 3, I want to throw the ball like this. Okay. So, when I want to throw the ball like this, it's going like this. Right? From this side, I throw the ball. Okay. So, from here, I throw the ball like this. Here, it is moving upward direction. After reaching maximum height, it's moving down. So, in this case, continuously the direction is changing. The direction, for example here, the direction from this point, tangential direction. From this, in this direction. From this, in this direction. From this direction. From this, like this. So, from each and every point, direction is changing. Not only the direction, velocity is also changing. Because from here to here, let us consider A, B, C. From A to B, gradually its velocity decreasing. Gradually its velocity decreasing because it is moving opposite to the earth surface. Gradually velocity decreasing. Not only the velocity, direction also changing. From point B, gradually velocity will increase because it's moving towards the earth surface. And direction continuously changing. So in the case 3, what is happening? Direction is changing, magnitude also changing. 3 cases are there. These are the concepts. Based on these concepts, in advanced, in 8 advanced also the questions are given very easy one. A body is moving continuously in a uniform circular motion with 10 meters per second. Now, after a few seconds, it reaches a point making the 90 degrees of angle in the position. Okay, here it may 90 degrees of join these two. With respect to the point, the radius of making 90 degrees. Now the object is at B. So you should analyze that concept. Present here like this. The radius, previous radius, this is the previous radius, this is the present radius. Is making an angle of right angle. Now, what is the direction of the velocity? Okay, so like this, complete examination questions will also come. Okay, so are you following? So don't forget that concept that what you are learning here. Each and every class, each and every concept is important. Don't think that we are not having board exam. Okay, right? So I have a life exam in coming days. So your 3 cases are there. Case 1, direction is remains constant, velocity changing. Case 2, direction is changing, magnitude of velocity remains constant. In case 3, velocity is changing, means magnitude of velocity changing, direction also changes. In all these 3 cases, one new terminology has came over there, that's acceleration. Now let us see what is meant by acceleration. The rate of change of velocity. The rate of change of velocity. Rate means a particular time. Okay, acceleration means the rate of change of velocity. Rate of change of velocity. Rate means at particular time. Rate means at particular time, not constant. Rate of change. Change means difference. Change means difference. Where is the change? In velocity. In velocity. So, it's a very easy thing. Where there is a change in the velocity, suddenly there will be the acceleration. Where there is some change in the velocity, suddenly acceleration will be there. But you may not wonder, here velocity is changing, yes. Here also velocity is changing. Here velocity is not changing, no? But velocity is a vector quantity. Velocity is a vector quantity which has both magnitude and direction. But here you see, here the velocity is towards north. If you come to this point, the velocity is towards west. At this point, from A to B, when it came to B, its velocity is 0 meter per second. Because towards north there is no any velocity. Now towards west only. Means change in velocity is there or not? Here 10 meter per second towards north. Here 0 meter per second towards north. 10 meter per second towards north. 0 meter per second towards north. Means there is change in velocity. So simply acceleration is nothing but the rate of change of velocity. The rate of change of velocity. Okay. Let us see that small derivation or formula how we can define it. Have you understood all these 3 cases? In case 1, direction remains constant, velocity changes. Case 2, magnitude of velocity same, direction is changing. In case 3, both are changing. Now, what is by acceleration? The rate of change of acceleration commonly represented with the rate of a. What is acceleration? Rate of at particular time. Rate means at particular time. The rate of change of velocity. Change in velocity. Change in velocity. Right. So acceleration A is equal to change means difference. What is the symbol for difference? Minus. By time means T. Where is the change in velocity? For example, a body starts with a velocity u. After some time, its velocity becomes v. Initial velocity is u, final velocity is v. Difference means minus. Where? In velocities. What is the initial velocity? U. Final velocity v. It's about initial velocity and final velocity. Difference means minus. So a is equal to v minus u by t is the formula. Change. It can be written like this. A is equal to difference means delta. Delta. Where is the delta? Delta difference. Delta stands for difference. Sigma stands for summation. So delta means difference. Difference where? In velocity. Difference in velocity by time. Of course, delta t also you can write difference in time. With respect to time, there is some change in the velocity. Delta v. Difference in velocity. Okay. Now formula is there. Then you will write the units now. Velocity. What are the units of velocity? Meters per second. Whole divided by time units. Second. Meters per second. Whole by second. Nothing is there when you compare this one like this. Then meter per second square. Meter per second square will be the units of acceleration. There are different types of accelerations also. Okay. Let us see once again what is acceleration. The rate of change of velocity. Means where there is some change in the velocity, certainly acceleration will be there. Different conditions they will ask. A body is having uniform magnitude of velocity, but there is no acceleration. Explain the motion. Understand? There is no change in velocity. Question is giving like this, no? No change in the velocity means magnitude. Okay, vector quantity. So direction is going to change. So you have to apply that concept and you should say that the object is doing uniform circular motion or maybe circular path. Okay, then velocity is changing. Maybe freely falling body, vertically projected body velocity is changing, both directions also going to be changes. Understood? Okay, so based on that, different concepts will come across this acceleration. In the coming classes, we will see those things also. Okay, have a nice day.